Okay. Today we are working with hyperbolas. It's our last type of new conic section. So ellipses were kind of like circles, but we elongated them. Hyperbolas are similar to parabolas. We're going to have, a hyperbola has two parabolas, either one going up and one going down, they go together, or one going left and one going right. So the hyperbola is two parabolas mirroring each other. Okay. Today we are going to be looking at finding the center and vertices. We're going to learn about a new term called an asymptote, and then we're going to sketch the hyperbolas. So first let's define what an asymptote is. An asymptote is a line that a graph approaches more and more closely, but never touches. Okay, so remember back when we were graphing exponential functions. So if I had something like y equals 2 to the x, and when we graphed it, it got really close to the y-axis, but never touched it, or the x-axis. You guys remember that? Yeah. An asymptote is the same idea. My line will get closer and closer to it, but it will never actually touch that line. Okay, so the x-axis in this case would be considered the asymptote. Okay, so hyperbolas have two of them. So a hyperbola has two asymptotes because there are two graphs right here. A hyperbola also has how many vertices, do you think? Two of them. If a hyperbola is made up of two parabolas, each one of those has a vertices, or a vertex, so there's two vertices. And then the center, as always, is h, comma, k. Okay, and the vertices, unlike an ellipse, where the vertices is the bigger of the two numbers, or the two sides, for a hyperbola, it's going to be whichever side comes first. And I'll show you what I mean in a second. Or, we could say, or whichever one is positive, x or y. Okay, so in a hyperbola, there's actually going to be subtraction involved. And when you see the form, you will know what I mean. So, an equation of a hyperbola. There are two different equations for a hyperbola. Okay, the center is always hk, so h is always what's attached to x, k is always what's attached to y. The only thing that changes is where x's and y's are. So remember how for circle, ellipse, parabolas, x always comes first, right? Now, the order actually makes a difference. If x is in front, x minus h squared, minus y minus k squared. If x is in front, the vertex, or the vertices, are on the x-axis. If the second equation is what happens, y is in front, the vertices are on the y-axis. Okay? B is always attached to y, A is always still attached to x. Okay? And your center is always, h is always attached to x, k is always attached to y. Okay? Also, we're always equal to 1. So what do you guys notice about a hyperbola that's different than an ellipse or a circle? What does it have that the other ones don't have? It has a subtraction, right? So hyperbolas has a negative between the x squared and y squared equation. So hyperbolas are pretty easy to identify because of that negative. Okay? And the vertices are always whichever one comes first, x's or y's, or whichever one is not attached to the negative. Okay? Okay, so when I am graphing these things, if x comes first, and I already explained this, if x comes first, then the graph is going right to left. So my two parabolas are going from right to left. They're sideways. If x comes first. So I'm going along the x-axis. If y comes first, then I'm going along the y-axis, which means I'm going up or down. Now, for hyperbolas, we are going to be asked to find the center, just like ellipses, the vertices, just like an ellipse, but we have another thing that we have to find, which are the asymptotes. Asymptotes are lines. There's no squared in either of them. We will always use the equation plus or minus b over a times x. So how many lines do you think we actually have? Because of this plus or minus, we have two. We have a positive b over a times x and a negative b over a times x. So they're always going to be exactly the same except they mirror each other. Okay? You will always use this. B always comes on top, so just kind of think of it as rise over run. Remember rise over run? The y comes first and then the x. Just a second. So B, what's attached to the y comes first, and then x is on the bottom. And then the last thing we want to note is hyperbola should always equal 1. If not, we can divide so that it is equal to 1. So just like an ellipse there. So let's graph it, and I'll show you guys what I mean. Okay, so example number 1. Okay, everything is pretty similar to how we graphed ellipses, except for the asymptotes. So, first of all, before I ask anything, well, let's find the center. What's the center here? 0, 0. So let's graph it right now before we forget. Okay, and then just like any ellipse, we're going to have to find which direction I go in the x direction and how much I go in the y direction. So x's, a squared is equal to what? 6. A squared is equal to 16, so a is equal to 4. So we're going to go right 4 spaces, 1, 2, 3, 4, and left 1, 2, 3, 4. In the y direction, b squared is equal to 25. So that means b is equal to 5. So I'm going to go up 1, 2, 3, 4, 5, and down 1, 2, 3, 4, 5. Okay, if this was an ellipse, the vertices would be the y's because they're bigger, right? But this is a hyperbola because of the minus sign. So where are my vertices at? The x or the y? The x-axis, because x is first. So I'm going to write that note. X-axis has the vertices because x comes first. Okay? So x-axis has the vertices because x comes first. So here are my two vertices right here. So let's actually write the equations. If my vertices are on the x-axis, does the y-coordinate change? No. So let's put those in right now, 0 and 0. Okay, since we're looking at the x-axis, we have to look at A. So what's 0 plus 4? 4. What's 0 minus 4? Negative 4. There's my vertices. Before I can graph any more, I have to graph my asymptotes. So, graphing my asymptotes are y equals plus or minus b, which is 5, over a, which is 4, times x. So y equals plus or minus 5 over 4x. Okay, these are actually two lines, right? Positive 5 over 4x and negative 5 over 4x. We need to graph these so that we know where to put the hyperbola, how we're going to draw it. An easy way to do this. This is, my y-intercept is 0, right? This is in slope-intercept form. Rise is what? 5. 1, 2, 3, 4, 5. Run is 4. 1, 2, 3, 4. So I would say put a little point there. Let's graph one more line, or one more point. Down 1, 2, 3, 4, 5. Over 1, 2, 3, 4. And we always draw asymptotes as dotted lines. So draw a dotted line all the way through the graph, through those 3 points. Now that's positive 5 over 4x. Which way do you think negative 5 over 4x is going to go? Just the opposite direction. So there's going to be down 1, 2, 3, 4, 5 to the right 4, or up 5 to the left 4. So it's actually going to give me two lines that are exactly the same except for the direction. So they should make an X. Okay? An easy way to graph these is if I graph all 4 points right here, did you guys notice that they made a box? And that the asymptotes go straight through the corners of the box? So what you can do to make it a little bit easier on yourselves, I would suggest sketching where A and B sends you. Sketch the box, and then your asymptotes are just going to go through the corners of the box. Okay? Okay, so my vertices are on the x-axis, so that means these are my vertices, which means my graph is going side to side or up and down? Side to side. Side to side. So let's graph those. So this is the lowest point, and I'm going to get as close to the asymptotes as possible without actually touching them. So we can't touch them, so we just follow them along. So it should look like that. Example 2, we're going to do this one together, and then I'm going to let you all try example 3 by yourselves. So example 2, first thing, let's find x or A and B. So let's do that first. So the x, A is equal to, or A squared is equal to what? 16. So A is equal to 4. So A is always underneath x, no matter where x is. Okay? Sorry. You're welcome. Okay, so then my y's, B squared is equal to 9, so B is equal to 3. So let's graph what we know so far. Where is the center? 0, 0. Okay, 0, 0. A is 4, so I'm going to go right, 1, 2, 3, 4. Left, 1, 2, 3, 4. B is 3, so that's up 3 and down 3. 1, 2, 3. Okay, I can draw the box right now, right? So let's draw that box. Okay. Question, are my vertices on the y-axis or the x-axis? The y, because y comes first. So y-axis, I'm just going to write that note again, has the vertices. Because y comes first. Okay, so my vertices are actually these 2 points, not these 2 points. Okay, so what would the points of my vertices be? If my vertices are on the y-axis, does the x-coordinate change? No, so they are 0, 0. I'm going to put them in right now. What's 0 plus 3? 3. What's 0 minus 3? Negative 3. Will it always be this way? No. Okay, will not always be the same as B if your center is not 0, 0. Okay, asymptote is y equals plus or minus B over A times x. So that's going to be 3 over 4 x. So y equals plus or minus 3/4 x. Those are two lines going through the corners of that box. So let's draw them. Okay. So these two diagonal lines are my asymptotes. Since y comes first, y are my vertices, is my graph going to go up and down or side to side? Up and down. So start at the vertices and give me two nice, these are going to be pretty wide, a hyperbola that gets really, really close to those asymptotes but never actually touches them. So that's what ours would look like. Okay? You guys okay with this?
Yeah.
Okay, it's kind of like we took an ellipse and then cut it in half and just split it apart. So what I want you all to do is try example 3 by yourselves. I'll set it up for you because this does not look how we want it to look. So example 3, we have x over 9, all of that squared, minus y over 4, all of that squared equals 1. So we need to distribute that square in first. So that's going to give me x squared over 81 minus y squared over 16 equals 1. And now you should be able to finish it yourselves. Okay guys, here's what I got. I got that my center was 0, 0, so I put that point there. A came out to be 9, so I counted those. B came out to be 4, so I counted those. I made my box, and I drew my asymptotes through the corners. The equation of those is y equals plus or minus 4 over 9x, so that goes down here. My vertices, because x came first, my vertices are on the x-axis, so y does not change for each of those. 0 plus 9 gives me 9. 0 minus 9 gives me negative 9. And that makes sense because that's where these 2 points are. So because x was first, they're going side to side. So as close to the asymptotes as I could get, I drew my parabola going side to side. How'd you guys? Last thing that we need to go over, how do I change it from something that looks like this to something that's in the form that we want? Now the instructions, just like on your homework, say standard. I want you to do descriptive, okay? Descriptive is the one that actually tells us the information we need to know. The good news is this is nothing new. So this is all stuff we know how to do. So we are going to group the y's. We're going to group the x's. Now the thing we have to remember is now we have negatives involved. So you need to make sure that you group the negative with the x squared. That x squared is negative in this case. I do not need to move x to the front because it doesn't matter where it is, but I want the negative 1 to be second. That's going to make it a little easier for us. Okay, so let's work on this. We can put in our blank, so that's going to be 4y squared plus 4y plus blank. Now, because there's no other x's, can I just rewrite it as it like this, minus x squared? I can. I don't have to worry about that one. There's nothing else in here. What do I have to do before I can complete the square? GCF of 4. So let's pull out a 4. Minus x squared equals 0 plus 4 times blank. And what goes in the blank? Wait, yeah, a 1. Wait, this was a 16. Oh, I'm sorry, guys. Change that x, I forgot. Change that 4y to a 16y. That's going to make our work a little easier. So after I factor out a 4, it's going to be 4y. Okay, so the problem had a typo. It was supposed to be 16. Okay, so now it goes in the blank. 4. Okay, so let's factor this thing. That's going to be 4 times y plus, what, 2 squared minus x squared equals 16. Okay, this is pretty close to what we want. What do we have to do next? Divide by 16. Now remember, this is standard form, the way it's written right now. I want it in descriptive, so divide everything by 16. And that is going to give me y plus 2 squared all over 4 minus x squared over 16 equals 1. Yeah. Question, what's my center? 0, negative 2. The x still has to come first, even though x does not come first in the form. Okay, but whatever's attached to the x still comes first. Are my vertices on the y-axis or the x-axis? on the y's because y comes first. Make sense? Okay, one last thing. I want to set up example 6. We're not going to be able to do it all the way, but because we have negatives involved, I want to make sure that you have something to go off of for your homework.
Are you talking about the
There. Yeah. Okay, so what do I need to do first here? I want to add 17 to both sides, and then I want to group them, right? What is going to come first, the y's or the x's? The y's, because y is positive. So that's going to be 4y squared plus 40y plus blank. Okay, and then I have negative 9x squared and minus 54x. Before you do anything, we're going to add those two together because that negative is attached to the x squared. It's attached to the 9. So we have to keep negative 9x squared together. And that's going to be equal 17 plus blank plus blank. Okay. Now what do I want to do? Take out the 4. So that's going to be y squared plus 10y plus blank. And then what do I want to take out here? This is where the negative comes in. So I'm going to take out the negative 9. And that's going to give me x squared plus 6x plus blank equals 17 plus 4 times blank minus 9 times blank, right?
So if you take out a negative, it doesn't change the sign for the third?
For this one?
Yeah.
Because we square it, it's always going to come out positive anyway.
Oh, okay.
So it doesn't really matter. And you guys could go from here, right?
Uh-huh.
The one thing I just want you to realize is that if there's a negative attached, you need to add the 2 parentheses first, and the negative will come out when we factor out the negative. But that negative is attached to the 9 there, so it has to stay. Okay?